Good evening. In previous session, we have seen the concept of decorators. So in today's session, we are going to see about generators in Python. So this is a important concept and we are having some advantages of using these generators. Okay. So 1 minute.
This conference will now be recorded.
Good evening. In previous session, we have seen the concept of decorators in Python. So in today's session, we are going to see about generators in Python. So here for generators, we are having some advantages. So let us see in detail about these generators in this session. So first, let us see what is meant by generator. So generator means which is going to generate something is called as a general generator. So we will see how the generator is going to be worked in our Python. So first let us see what is meant by generator. So if you are going to consider a power generator, I'm going to consider a power generator. It is going to generate power. Okay. In the same way, if you are going to consider a generator in our Python, it is going to generate something. So let us see what is that something and how it is going to generate the values in our Python by using the concept of generators. So first let us see the definition of generator so that we can go for the examples. So already we are seeing the concept of functions now. In previous session we have seen the concept of decorator functions. Now we are talking about generator functions. So here a generator is also a function. Generator is also a function, that returns an object which is iterable, which can iterate. Okay, that is iterate is nothing but we will get one at a time. Okay, iteration means we are going to get group of values, but here we are going to consider one at a time. So this is very important concept. Once again I am repeating the definition. Here generator is also a function which is going to return an object which can be iterate. That means directly I can say that here generator is a function which is going to return multiple values. So why I am going to telling about returning the values means, if I am going to consider a small program, let us consider define some function. Here I am going to write some return 10. If I am going to write return 10, let us write once again. I am going to write return 10. Let us see return 20. I am going to write. If I am going to call a function here, let us see what happens. So see here, it is not going to do anything here. Okay, once I will print this one, print of function I am going to call. So see, it is going to print only 10. What about return 20? It is not going to consider second return. It is only considering only first return. If you are going to return n number of returns, observe here, I am going to write one more return here. Here I am going to write some 30 value. And here I am going to write some 40 value. So if I am going to execute this function, only the answer will be only 10. Because in our function, if you are going to consider any normal function, it can return only one value by using a keyword called as return. But now if we want to return multiple values from the function, so then I have to go for the concept of generators. Okay, so I think you have understood this one. So if I write only one return, if I write one return or if I write multiple returns in our function, it is going to execute only one return. But now if I want to return multiple values from the function, then I have to go for generators. Now one more point I have to tell. Here I am going to pass some 10 comma 20. For example, here I am going to write some return a comma b, and here I am going to perform a plus 1. Okay, now observe. So see the output what we are going to get, we are getting a 11. That means here whenever I am going to pass the value 10 to this a, it is going to be incremented and the value is going to return to this function. Okay, now here I am going to print a value once. 1 minute. Here as we are not, this a is in which scope, this a is in the scope of this function only, so we cannot print this a value. Anyway, just I will write here a equal to 10 and I am going to write b equal to 20. For example, I am passing some a comma b. Okay, now see what is the answer. I am going to get 11 and 10 because this a is different and this a is different. So this a value is not going to be modified here. The value that is present inside a is going to be, sorry, the value that is present inside a function is going to be modified. Now the second point in this generator is, if you observe this generator concept, it will be same as the normal function what we are seeing now, but only one concept is different. That is, if we say any function as a generator function, it should have yield method. It should have, sorry, yield keyword, sorry, yield keyword. So in Java we are having yield function, sorry, yield method. So in our Python we are having a yield keyword. So if any function contains yield keyword, then I can say that that function is a generator function. Okay, so now here in this function what I am having a yield keyword, so that I can call this function as a generator function. So what is the use of this generator function? It can generate or it can iterate the items of this generator function. Okay, let us see. For example, here I am having two things. One is yield a and another means I am going to write some yield b. So if I call this function with print, I am going to write some function of a comma b, for example. So observe this. 1 minute. Okay, a is not defined. 1 minute. Okay, see here, it is going to return some generator object. Observe one thing here. If I call this function, what is going to be happen? It is going to call this function and it is going to return some generator object. So if I want to print the values of generator object, I have to use one function. Observe one thing, I have to use one function called as next function. That means first I want to assign some other name for this generator object, and now if I want to get multiple values from the generator function, I have to use a function called as next function. Observe this, next of f. Next I am going to write one more, next of f. Observe this one here. What happens here means function f of 10 comma 20. That means I am calling here, the values will go to here, and f contains what? So it is going to return some generator object. Already we have seen here. It is going to return what? Generator object. So it is going to store which object? F is having which object now? Generator object. So let us check whether it is having generator or not. So print of, I want to see the type of F. So here it shows what? It is a type of generator. So observe that it is going to show you what? Class generator. So F is containing what? The object of type generator. Now here I am calling function of 10 comma 20. A value is what? 10. B value is what? 20. So first when I say yield of A, then what happens means whenever I am going to say yield of A, the value is going to be when I call next of F, it is first value that is going to return from this yield. Next, after that, the control backs to here. Next statement is what? Next statement is yield of B. That is, sorry, yield B. When I call next step, it is going to give me yield value. For example, I will write some other statements in between these yield methods. So then you can understand what happens here. So print of, I am going to write after a value. After a value. So now see, you can understand clearly. See, first what happens? Class generator, because I'm going to ask the type of the f. Now, when I call next of f, what happens? The yield keyword which is present in f. What is f? Generator object. Which generator object? This function generator object. So it will go to this function and it will check for first yield. What is the first yield? That is a. So it is whenever I'm going to ask next of f, it is going to give me a. Next, after that, once again, if I ask next of f, what happens? It will go to this function and it will check for second yield keyword. What is that? We are having b value. So it is going to print b value. For example, if I am going to next of f, is there any yield keyword other than these two? No, there is no other next. Then what happens? We are going to get an error saying what? Already the iteration is stopped. What is meant by iteration is stopped? So first what I'm going to do? Next of f. That means it will go to this function and check for a first yield keyword. So it is going to give me 10. Next time I'm going to this function and I'm going to call yield b. That means it is going to return what? B value. Next, I'm going to call next of f. Is there any next keyword here? Nothing is there. So if it is there, for example, I'm going to write one more yield here. Then let us write 30 here. Now what happens? We are going to get the answer 30. If once again I'm going to write without any yield, how many yields are there? 3 yields are there. So if we want to call those 3 yields, I have to use only 3 next functions. If you use one more next function, is there any yield keyword to return some value to our calling function? No. So that what happens, it clearly says that the iteration is completed. The iteration is what? Completed. So we should not have more than 3 next functions here, because here we are got 3 yield keywords. Observe carefully. Now I am explaining clearly. First, see here, the control goes from here to this function and it will go to this and it is going to yield. That means what? It is going to give the value, and here the value 10 is going to be printed. Next, when I go to next of f, it is go to second what we can say yield keyword. So here it is going to print what? B value 20. Next of f, that means it will go to where? Third yield keyword, and it is give me what? 30. Observe very carefully that whenever we are going to write next of f, the value is going to be returned to this caller function. That means from here the value is given to this caller function. That means I am coming out of this function. Once again, I am going back to here after returning the value. So here we can understand that. Let us once I will explain once again clearly. See, whenever I am calling what? Next of f, which one is going to be returned? This is called. That means the value is going to be returned back to here. Sorry, this one here. That means 10 is going to be returned here and it is going to print that. That means the controls come out of the function. After completing the task, after returning this value to the calling function, once again it will go here and it will print what? Next statement, that is after a value. Next, what is there? Yield b is there. Yield b means whenever I am calling next of f, it will come to here. Next, if yield of b is there, next it is going to return this one. Let us see if we are going to write yield of some yield a, yield b and yield 30, and here I am not going to write any next functions. Let us see what happens here. Observe this. I will remove these 3 next functions. Now observe. What is going to printed? Only class generator because of this type. If I remove this one also, what will be there? There will be no output. Reason is what? Reason is I am not asking to return back the values from the function, so that it is not returning anything. If I ask a function to give something, so it is going to give what? Next of f means for f what function is associated? Function of 10 comma 20. It will go to that function and it will get back which value? A value. After this we are going to get what? This one. Next of f, what is that? We are going to get b. Next of f, we are going to get what? 30. In this way we are going to get the output of the program. So now see, if I execute this one, you can observe here, if I execute, what happens? We are going to get all the values. So this is about generator. So you may think that, so instead of writing yield, let us try with return here. then what happens? Let us check. So see here, if I write return here, it will give only, it may lead to error. So observe that thing once. So see what happens. Int object is a not iterable. It's going to tell what? Int object is not an iterable. So here printf is there. Just I will remove all these things. Just I will print only print of. I will call that function. Just I will use this one here. Generally, what should be happen? The value has to be printed when I am going to use return here. So see what it is going to print here, only 10. That means when I am going to use return inside a function, the control comes. See here what happens in this case. When if I am going to use the return, function calling is done here, and in this what is there? Return is there. That means I'm coming out of this one and giving the value here, that is 10. What about these three statements? These three statements will not be executed. Reason is, once we are going to use the return, that means if we are going to return from the called function to the calling function, that means what? This is called as called function, this is called as calling function. From here we are calling this function, so this is called, so this is calling, so this is calling function, and this is called function. Once if we are getting out of the called function, then we will not enter into that called function. So here return means what? The control comes out of the this function, called function, so we will not go back to these lines. So this is about return. So to overcome this one, what we are going to use? We are going to use the concept of yield. Yield method, what happens? When I am going to write yield, it can come out of the called function and it will go back to that called function once again. That is the advantage of this yield keyword. Okay, not yield function, it is a yield keyword, right? So you understand about this next trend. To retrieve the values, we are going to use what? Next one is what? To get the value multiple times, iterable, that is that multiple values from the function, then we are going to use what? Yield keyword. Now let us see what are the differences between generator function and normal function, so that we can go for different examples after knowing the differences. If you are going to consider a generator function, it can contain one or more yield functions. Already we know, if you are going to write a normal function, there we can have only one return. It will execute only one return. If you are having multiple returns also, it will execute only one return. Next, when called in this is generator, and next this is what? Normal function. Okay, now when called, it returns an object. Whenever we are calling a generator, it is going to return what? Object. Okay, which object? It is going to return a generator object, and it is going to give what? The values iterable object. That means it can give multiple values. Okay, this is about it is going to return a object which can be iterable. And one more thing, that is, but does not start, it does not start execution immediately. Here the important thing. So I will show you the output. I will take the time and I will show you how the generator is going to work. Next one. Here, once the function yields, already we know yields, yield keyword is used. Once the function yields, the function is passed. That means once we are coming out of, if here yield is there, example, here yield is there, and here also I am writing some yield. Okay, observe this one. Here also I am having some yield. Now what happens? First it is going to return 10. And that means it is going to return 10 means what? This function is halt. It is going to return 10 to this one, and again it is going back to this function. That means sometimes whenever we are going to use this keyword called as yield, the function is passed and the control is transferred to where? To the caller function. When I use yield keyword, the control transfers to called function. This is a calling function. Okay, once after completing this one, again it is going back to called function. If once again yield keyword is there, again it is coming back to calling function, and so on. That means here sometime it is going to be passed. Okay, right. Now let us go to some examples that we have seen till now. Okay, last one I want to discuss about return and yield. What is the use of this return means? So here the difference is that while a return statement terminates, when I'm going to use a return statement in my function, it terminates a function entirely. That means once we are going to use return, the function stops at that particular point. But if you are going to consider a yield statement, just it is going to pass that function. After it is going to return the value, once again the function is going to execute. Once again, if yield is encountered, then what happens? It is going to pass once again and so on. Okay, this is about the concept of generator functions. Now see, we can also have, if I write here return, see what happens, you can understand clearly. See here, here just I will write some fi I'm going to call. It is going to return what? Yield, because first here we are having yield. Now I am going to write this f equal to 10 comma 20 and 1 minute. Here I am going to write what? Print of next of f. First it is going to give which value? It is going to give a value. Next I am going to print here b value. Let us see what happens here. Here will we get an error? Yes, because third yield is not there. So we are getting an error here. For example, I am writing only two things. What happens? Only 10 and 20 is giving. It is not going to return any value, because initially we are using, as we are using yield method, it is going to return which type of method? It is going to generate a, this function is going to be considered as what? If we are going to use at least one yield in your function, then that function is going to be considered as generator function. So this function is going to return which object to this f? This f becomes what? Generator object. So if you are going to use next to that generator object, it will give you what? First yield value, second yield value, and here we are having return. It is not going to return anything, any normal value. Okay, let us see. Here we are having only return. Let us consider there is only return, and I am going to print here type of f I want to print. I am printing type of f. Let us see what will be the type of f here. So observe that it is a type of what? Int, because the value that is going to return is what? 30, and that 30 is going to be stored in f, and I am finding the type of f. That means whatever the value that is going to be returned by the function, that is what? 30. So the type of f will be what? 30. Sorry, int type only. So this is about yield and return. The combination of yield and return will not work. If we write also, there is no concept of getting an error, but return is not going to be executed. Now one point I want to discuss, that is, once the function coming out of the, see here, just I want to write something here, that is a equal to a plus 1 I am going to write, and here I am going to print of, just I will take only one value, that is a. I am calling fun of a, fun of some value I want to pass, sorry, 10. Here I am returning this one. Let us consider returning this one. Okay, now see, if I execute this one, 1 minute, sorry, this is 1, not L. Okay. Okay, we are getting the answer as what? 11. Once again, if you are going to call the same function, listen carefully, if you are going to call the same function with same other value, let us consider okay, some 10 only I'm going to consider. Here what? We are going to get 11 only. You have to get what? Generally you will think what? Once if I am calling a function of 10, what should be happen? 10 value has to be go here, and a value is what? 11 now. And what happens? Again I am passing 10. Already a value is 11, it has to be 12 generally. But here what happens means, in first function call, in this function call, the a value is what? 10. and 10 plus 1 will be returned back. So at that time A will be destroyed. Very important point. Listen carefully. Once we are going to get out of the function, automatically local variables are going to be destroyed. That is, see here 10 is passing to where? A. That means one A is going to be created and here 10 value is there. So here what I am doing, I am incrementing the value by 1. So A value is what now? 11. That is returned back to here. Now we are coming out of the function here. Then what happens? This variable is going to be deleted. A is going to be deleted and value is going to be sent to here. Okay. Next, if you are going to send once again 10 value here, again what happens? A is going to point to 10 and again it is going to increment 10 only. That means here the values are not going to be retrieved once again. That means the values are not going to be stored between the function calls. Once we come out of the function, the values of that function is going to be deleted or destroyed. But in the case of yield, the values will not be destroyed. Very important point, this one. The values will be retained. The value of any variable is going to be retained. That means it is going to contain same value. Now observe, very important point. This is just I am going to take one function here, and here I am going to take some n value as 1, n equal to 1. So what is the rule of return here? Once, not only return, what is the rule of local variables? Once we are going to get out of the function, local variables of that function has to be deleted. But by using the concept of yield, the function local variables will not be deleted, right? Now let us see here. So I am going to print, this is first I am going to print, otherwise just I will print first here. Next I am going to yield n. That means I will get what? N value I am going to get. What is the n value here? 1. Okay. Next, I want to increase the value of n. That means in this way also I can write, just after increasing the value also, I want to send that by printing second. Okay. Just I will yield that value, yield of n. Next, n plus equal to 1. Again, I have incremented with 1. Just I am printing third value. For that, I am writing here third. Now the value is what? N plus equal to 1. Now 3 times I have incremented. After incrementing this value, oh sorry, already incremented this value. Now just I will write yield of n I am writing. Observe here carefully. What happens? What will be the output of my program here? Just I am going to write some f equal to some function I am going to write. Now it is going to, I am not going to pass any value here, so that just I will remove this one. Now I am going to print next of if I am going to print. Then what happens? First n value is going to printed, next n value is going to printed, third also n value is going to be printed. Here we have to observe very carefully, listen carefully here. If we are going to use the concept of return, what happens? From here, let us write here, I think I have written some return n I have written here. That means what? We control comebacks to calling function, and that value is going to be printed here. Once again, if you call the same thing, for example, again what happens? Same value is going to be written, same value is going to be written. That means here, if you are going to use the concept of return, once we come out of that function, the values are going to be destroyed. Once again, if you are going to enter into that function, that variables are going to be created. But if we are going to use the yield keyword, what happens? Now let us see here. N value is what now? 1. This n is what? Local to this function. So if I call next of f, which value is going to printed? This value will be printed here. That means this value is returned to this one. That means here what happens here? N value is what? 1 will be printed here. Now if I come out of this one, what this variable has to be? It has to be destroyed. But as this is the yield keyword, this function is not going to be what this variable is not going to be deleted. It is, the function is going to be passed. It is not going to be terminated. It is going to be passed, and again it go back to here, and it is going to perform what? N equal to n plus 1. Now yield n. Now again it is going to do what? It is going to perform, it is going to print 2. Once again It is going to increment the value as 3, and finally it is going to print what? It as a, sorry, it is incrementing to 3 and it is going to print value as what? 3. Once we are going to get out of this function also, we are not going to it is not going to destroy the local variables of that function. This is very important point. So what should be the output of this program? The output of this program should be what? That is 1 2 3 should be the output. So see the output. So I will write with the written also the same program, so that you can understand the difference between written and this yield. 1 minute. Here just I have not placed the single quotes or double quotes, so that we are getting an error. So see, we got what? 1 2 3. Okay. If I write instead of this one, just I will write written here. Written. I am going to write. What will be the answer? Just it is going to give me the answer what? Stop iteration. Just it is going to print what? It is going to print first and it is going to use stop iteration. Why it is stop iteration? Because I have used here next of f. Okay. Because of this, it has ended stop iteration. So when we are going to get stop iteration error, if already the values of this function is iterable object is completed, that means the values of iterable is not present, then if we are going to use next function, then we are going to get stop iteration error. That means here what happens? Here I am having 3 yields. So first yield for this next step, second value for this next step, third value for this next step. If I write once again this see here, if I write once again next of f, we are going to get what? An error saying stop iteration. Okay. So this is about yield. One main important point we have to understand about this program is, once we are getting out of the function also, local variables of that function are not going to be terminated. The value is going to be retained. Retained means it is going to have the same value. Okay, right. But if you're going to use the concept of return, the value is going to be destroyed once we come out of that function. Okay, here the value of n is what? Not going to be destroyed. If in a normal function, local variables what are going to be, local variables are going to be destroyed in the case of return. In the case of yield, the value is going to be retained. Right. Now just here every time I am going to write what? Next of f, next of f, next of f. So 4 times I am having yield, so that I am going to write what? Next of f. Why I am going to write here next of f? Because this f contains, f is which object? F is a generator object. That means that object is having the values. Which values? First yield value, second yield value, third yield value. So if f contains 3 values, just can't I write for loop here? For example, I can directly here for I in f. That means f is having how many values? 3 values. Which values? First n value, this value, that is 1, this value 2, this value 3. So just if I print the value of I here, what will be the output of my program? Output of my program is 1, 2 and 3 is going to be output of my program. So that is what 1, 2, 3 is going to be printed. Yes, this is the concept of using the for loops with generator object. Now I want to write a small application by using this generator concept to reverse the number, to reverse any object. I will take some string here. So for reversing, I am going to take some string. I want to pass that string here. Some s I am going to take. Okay. So what I have to do? I have to reverse. Already we know the logic of reverse. Just first I want to find out the length. So that length equal to what I have to do? Length of len of s. That means we are going to get what? Length of that particular string. So for reversing, what I have to do? For I in range of, just I am going to add some logic here, that is length minus 1, that is last value it is going to give you, and next -1 comma -1. Here what we can understand? Start value, n -1 value. N -1 is what? 0 here. We are going to get in a reverse order. So we can observe the output. Just I will print what? Every time I don't want to store the value, just I want to yield the value. Just what I want to yield? Here I want to take S of I. That means I want to yield what? S of I. So S contains what? String. Just after completing this one, just I will draw a small diagram for the string and you can understand. This is the concept for what? This is the concept for returning the reverse of the string. Now for that I want to pass one string by using a for loop. So for just I am going to take for C in reverse of, I want to call that function rev of, I want to pass some string here. Some I am passing some string here, right? Just I want to print that character. That is nothing but C. Now observe carefully. So here what I'm going to reverse a string what I am passing from here. So rev, that means I have called from here. Okay. Here in this S, what we are having, Sivaram is going to be there. Length is going to be what? 1, 2, 3, 4, 5, 6, 7. Length will be 7. And here, this will be 7, this will be -1, this will be -1. Okay. It's going to print from 7 to 0 in reverse order. Okay. Next one. So next what we have to do here, after going to see that for loop, we are going to enter into this yield of S of I. S of I means what? Seventh element. What is the seventh element in Shivaram? M. That is going to return back to here. This function. Okay, that means here what it is going to return? M. It is going to store it in C and it is going to be printed. This is first case. Next case what happens? Again it will go back to here because already one yield is returned. Again it will go back to here. And here what happens? Next 6 it will become what? 6. Next I value will be 6. S of 6. A will be printed. Next again it will go to here. Next value is what? 5. Next what happens? R. Next A. Next V. Next I. Next S. In this way I am going to perform the reverse operation by using the yield keyword. So one thing we have to understand clearly is by using yield, it is not going to store anything. It is not going to store anything here. Directly it is going to return. That's it. It is going to print. That's it. It is not going to store any values. Here it is going to return how many values? It is going to return 7 values here, but it is not going to store anything. Okay. So now just I want to execute this program. So see what happens here. It is going to reverse the given string. Very important. So generally what we have done, we are going to store this function into a one f or some g or something, and we are going to call next of f, next of f, next of f to get all these values. But here I am going to use what? For loop I am going to use. Here I am going to use the, I am going to call the generator function. So generator function will return what? Yield, first value, second value, third value, fourth value, until the range of this particular condition. It's go on return some value to here and it's going to print that values. So this is about generators in for loop. So we can also write many examples, but okay, one more example I will show you. There I am going to use two functions. Okay, what is my concept means? I want to select only even numbers. Okay, I want to select only even numbers, and I want to print the squares of that even numbers. That is the concept. Okay, so that I'm going to write a small function, define even. This function is for to find the even numbers. So already we know for I in range of, I want to print what I will give. If I give 10, it has to select only even numbers within the before 10, and it has to perform some squares for that one, and I want to add them also. Okay, now see range of nums, whatever the num value I have passed to nums is going to perform everything in this for loop if I modulo 2. Okay, I modulo 2 equal to, that means what? Even number. It will be even number, so that I want to give that value. I want to yield of I. If it is not a even number, it is not going to yield. Okay, right? This is one concept. Next, to whom it has to yield? To perform sum of that one, sorry, squares of that I. So again, I'm going to define some function. Define square of NUMS. Okay, for example, here I'm going to write what? For NUM in NUMS, I am going to write yield of num exponential 2. It is going to be a square. Now observe carefully here what is going to be happen. You have to understand clearly. Just I am going to use some function. Sum is going to add all the values of that. I have passed it to that sum function. See here what I am calling. I am calling square. For that square I am going to pass even of 10. So observe here carefully. What happens means here. First I am going to call what? Sum function on square. It is going to call what? Even. So it will go to, observe carefully, even of 10. First it will go to here. Okay. Next, I in range of nums. First value is what? I in range of 10 means 0. The value will be 0. So 0 percentile 0. Is it 0? Yes. So yield 0. That means here the value will become what? 0. And next, square of 0 will be called. That means here. Okay. Next, num in 0. That is not 0. 0 will be considered. 0 square is nothing but what? 0. Completed. Sum of that 0 will be done. Again, even of next has to be done here because loop has not been ended here. It will done for, sorry, yield function is not ended here. Next one value 1 percentile 2 is equal to 0. No, so that it will not go for yield. Next, third one, I value is what? 2 percentile 2 0. Yield I, the value will be sent to here. That means which value? The value 2 is going to be sent here. That for that square is going to be done and the value is going to be written here. Okay, and it is going to be summed. Okay, finally in this bracket for sum we are going to get what? 0 square plus 2 square plus 4 square plus 6 square plus 8 square. Okay, that means because I have taken only up to 9. If I pass 10, what happens here? 10 will be passed, but the range of 10 will take what? Up to 9 only it will take. Okay, now see, 1 minute. Here we are having some brackets issue. Here we should have one more. See what we get? 120. Okay, that is sum of squares of even numbers below 10. 10 is not going to be considered below 10. So in this way we have to perform.